I'm going to go ahead and cover this topic in this intermediate algebra course, but let me warn you, depending on your instructor and your institution, this topic may not be covered until you get to a college algebra course. But the topic I'm talking about is a topic on complex numbers. And you'll actually see a little bit later when I talk about quadratic equations that I kind of make the disclaimer that if you haven't discussed complex numbers yet, then some of the solutions that I get, which involve imaginary values, I ask my students to ignore them. So if you see some quadratic equations in the next chapter that have answers that look unfamiliar, that have I in them, that's because you get complex solutions. So anyway, it just depends on what's covered in your course. So if it is covered in your course, then I'm going to provide you with some good info here about complex numbers. The first thing I want to talk about with complex numbers is I want to define what we mean by I. Now, I stands for imaginary unit, and so we know the square root of -1 is not a real number because there's no number that you can square and get -1. If you square 1, you get 1. If you square -1, you get 1. But you can't square a real number and get 1. So we're going to assign I to represent the square root of -1. So then, if I is equal to the square root of -1, then if we squared both sides, then of course I squared would equal -1. Okay, so now that we've defined the square root of -1 to be I, we can now find the square root of a negative number. Now, I'm going to assume that a is a positive number in this radical. Therefore, when I do negative a, I'm truly getting a negative number. So if I take the square root of negative a, then that's the same as the square root of -1 times a, where a is a positive number. And we know the square root of -1 is I, so I can take that out of the radical as I times the square root of a. Now, let me show you some examples of that. Since I know that square root of -37 can be written as the square root of -1 times 37, then I can write this as I times the square root of 37. So basically, I'm just going to use this property, and I'm not going to do the middle step here where I broke it up. Anytime you have the square root of a negative number, you can write that as I times the square root of the positive number. So here I have the square root of -36, and I can write that as I times the square root of 36. And since the square root of 36 is 6, I'm going to call that 6i. Generally, you put I to the right of an integer or a whole number or even a fraction, but if there's a radical involved, we generally put the I to the left of the radical, as you'll see in the next example. In this next example, I have square root of -50, so that's going to be the same as I times the square root of 50. And then square root of 50, remember, we can write as 25 times 2, and we know the square root of 25 is 5, so I can pull the 5 out, and I'll write 5i times the square root of 2 because the 2 stays in the radical. So notice here I wrote the I to the right of the whole number 5, but I wrote it to the left of the square root. The reason that we do that is because if you had written the I over here, it's easy for the I to get actually mistakenly put inside the radical, and of course we don't want the I inside the radical. So 5i square root of 2 is your answer there. And then here's another one similar to that. Square root of -28, that's the same as I times the square root of 28. And then 28 is 4 times 7, so you can take the square root of 4 out of the radical, which is 2, and you have to leave the 7 in the radical, so that would be 2i times the square root of 7. Now, what we're really leading up to are complex numbers, and a complex number is a number that can be written in this form right here, a plus bi, where a and b are real numbers and I is that imaginary unit. So let me show you some complex numbers, and then I'll show you what represents the a component and what represents the b component. So here's the first one, 3 plus 2i. Well, the real part is the 3, so that's the a component, and then the coefficient of I is 2, so 2 is the b component of that complex number. Alright, here's a fraction. Here's one that involves fractions. You have 2/3 minus 1/2 I. Well, the real component is the 2/3, and the coefficient of I is actually negative 1/2. Alright, now let's look at this one. We have 3 square root of 2 minus 5i square root of 3. Okay, the real component is the 3 square root of 2. Oops, kind of covered that up there. And then the imaginary portion, or the non-real portion, is actually the minus 5 times square root of 3. So minus 5 times square root of 3. So you have to think of that. If you think of that, that's really, remember, this times I. That's another way to write this minus 5i square root of 3 is to say minus 5 square root of 3 times I. So therefore the coefficient of I is minus 5 square root of 3. But we generally don't put the I to the right, so that's why I have the I in the middle. I explained that earlier. And then any real number is considered to also be a complex number. So this is a little bit confusing to students. It turns out that the set of all complex numbers does include real numbers, because a real number can be written as the number plus 0i, where the real portion is the real number and the imaginary coefficient would be 0. Now you can also have a pure imaginary number, which is what these are called when there's no real portion. So this is a pure imaginary number, 3i, and it can be thought of as the real portion can be 0, so it's 0 plus 3i. So the real portion here would be 0, and the imaginary coefficient, or the coefficient of the imaginary portion, is 3. And then I went ahead and just threw in 0. 0 can be written as 0 plus 0i, where the real portion is 0, and the coefficient of the imaginary portion is also 0. And so that's basically what these complex numbers consist of. These are just several examples of complex numbers that you could run across. Okay, I'll end this section with a couple of complex numbers that you can simplify. Here you have a square root of 72 minus the square root of negative 49. Now, I know this is going to be a complex number because I know I have the square root of negative 49 here, and so I know that it's going to involve I, so we're going to have a complex number. So first of all, let's simplify the square root of 72, and we can write that as the square root of 36 times 2. And then the square root of negative 49, we learned we can write that as I times the square root of positive 49. And now if I simplify these radicals, the square root of 36 is 6, so I can pull that out of the radical. And so the real portion is 6 times square root of 2. And then the imaginary portion is actually the square root of 49, which is 7 times I. So we have I times 7, which I'll just write as 7i. And so we have 6 square root of 2 minus 7i. And that simplifies that one. Uh-oh, it sounds like the police are coming after me, so I better go hide for a few minutes. I don't know if you heard those sirens or not. Okay, so this next one, I have 2 times the square root of 75 plus 5 times the square root of negative 200. So I can take the square root of 75 and I can write that as the square root of 25 times 3. And then for the square root of negative 200, I can just take the I out and write that as I times the square root of 200. Okay, now on this one, I know I can take the square root of 25 out of this, which is 5. So I'll have the 2, which was already there, then times the 5, and the 3 stays in the radical. So I have 2 times 5 times square root of 3. And on this one, I have the 5i, but I can write 200 as 100 times 2. And I'll simplify this in the next step. Now here I have 2 times 5, so I can write that as 10 square root of 3. And then here I can take the square root of 100 out of the radical as 10. And so I have 5i times 10, and the 2 stays in the radical, so times square root of 2. And so finally, the real portion, I just bring down the 10 square root of 3, and then the imaginary portion, after I multiply 5 times 10, I get 50i times the square root of 2. Okay, so that gives you a pretty good understanding of what these complex numbers are. And in the next section, I'm going to talk to you about operations on complex numbers.